Hi, my name is Peifeng. I'm gonna introduce my part, which is the pre-aggregation for SQL query optimization. So in order to fulfill that, before all the implementation, our motivation is that, for example, when there's sorting rows for group by department, maybe instead of outputting CS1, CS2, CS3, if there's something like a sum operation, then maybe we should just output CS6. So this can minimize the intermediate data size. So by doing that, the main upgrade is this new merge sort with pre-aggregation algorithm. So in this algorithm, basically we define a new buffer here called exe sort buffer with aggregation. So for this new buffer here, as you can see, compared to the traditional sort buffers, which rows are buffered flush to disk once the memory is full, and final merging simply ensures the sorted order with no aggregation. In this new exe sort buffer, we have defined it by split each row into a group key and an aggregate state. So when the multiple rows with the same group key appear during the merge process, their aggregate states are combined. Use the code string merge function here, which hasn't been used before in the traditional version. And then we can do a sort and merge, use this buffer. So back to this operator, we have for this upgraded merge sort, compared to the traditional query plans where there's a merge sort pop, first sort rows based on group by keys, and then go to the aggregate pop where the process those sorted rows and computes the aggregates. Now we are able to combine two steps into one. And in this aggregate in this aggregate process, we are able to avoid unnecessary buffering. So as you can see, we have the group key and the partials being added into the buffer. And for each step there, we are able to do the add, do the merge, do the sort first, and do the merge, use the merge functions. And in order to fully support this new merge sort algorithm, we also have to update the planner as well. So in order to support this, the query planner was extended to detect when pre-aggregation is safe and beneficial. This integration ensures that the system automatically uses the new operator when possible without requiring manual operations. So you don't need to turn it on or off. It just automatically determines if it could be used or not. And during that process, we have a new group by helper function called add group by sorting version 2. So in this function, we replace the traditional one. As you can see here, we will know if this aggregate expression is incrementally computable and if it could support the code string merge interface. And if possible, we're going to call this new helper function in the planner to actually optimize the running process. So now let's go through some actual test cases. So as you can see here, if I comment this out, and if I put this back, this will be the traditional smart planner as we see before. So let's run this on the traditional version. Set planners. So here, let's first try this query where there's a single group by operation there. So And as you can see, the result I have already pasted there and the estimate IO as well. And let's see this one here. So also the difference is that there's an actual argument here, which is the max. And this one is different because there are two different variables in the group by algorithm. So as you can see, the result I have already pasted that, and the estimate IO is here. The actual IO is because the group by operation involved. So let's see what if we have the optimized version. So in the smart, let's put the optimized version back. And let's run it again. So let's first try this one, which is the single group by operation. And you can see the result here is correct. And you can see the IO here is actually optimized, which is now 6,519. And let's try the another one. So this one is like there's an actual argument. And as you can see, the result is correct. And also you can see the merge sort with pre-aggregation pop has been caught here instead of the traditional version. And the third one, this one, there are two variables in the group by, and you can see the result is correct, and the IO has been optimized. So that's it for my part. Thank you.
Hi everyone. So in this demo, I'm walking you through my implementation of the piggyback aggregation in our Devil database system. So this feature is realized through a new physical operator called sort aggregpop, which enables early aggregation during sorting, improve both memory usage and performance, especially for group by clause in the queries. So let's start by looking at the class itself. So stored aggregpop is a subclass of qpop and is defined in the stored aggregate Python. Its goal is to perform aggregation incrementally during a sort phase. The core idea is to process sorted input and maintain a current group state and emit a result only when a group ends. So inside this class, I defined a compiled prop data class to hold all executable versions of group by and aggregation expressions. The constructor takes input pop group by expressions, aggregate expressions, and um, their allies and an optional having condition. Um, so in our system, so we are using batch mode execution. So the core execute method decorated with the profile generator. First, it collects. It's here. So first is class all rows from the input operator into a list using list self-input execute. Then it sorts this list in memory by evaluating the group by expressions. This is a simple in-memory sort for now, but it can be replaced with external sort in heap file, like probably in the future. Once sorted, the rows can scan sequentially to detect group boundaries. As we proceed each row, we compute this group by using compile the group by group by excuses, and if the key changes, we finalize the current group using the the compiled agree finalized excuses and emit the result. Otherwise, we continue update the aggregate state using the compiled agree add excuses, which incrementally build aggregations like sum or count. Those aggregatable also, let's move to how sort agripop is triggered. So this is happening in our smart planner within the smart planner optimization block function. So we extended from the milestone 4 and with this function can use sort aggregate. We check if we can use the sort agripop the operator. After generating the best plan for query block, I check whether the query has a group by clause and whether it's eligible for piggyback aggregation. That check done by can use sort agree, and which ensures all select expressions are either simple aggregations or group by keys. So if the conditions are met, the planner will add a sorting operator using add group by sorting. Here. Uh, and then cause uh like if it is not, we just fall back to the original agripop. Um, so yeah, and also in the test cases, we can see so with this simple query that we built, it's like from the task queue query that from milestone 4. The table is from milestone 4, but we here just like test it with the simple group by clause as we can see here. So that we are like successfully triggering the sort agripop, and the physical plan is like have an estimated IO cost like around 22. But the point is that we haven't been successfully there is compared to like other with like the milestone 4 the IO cost to be really like hugely improved, but the idea is here, so we were checking the pre-aggregation functions. So thank you.